Hello everyone, and welcome to my series on Docker. If you are wondering what that intro was, it is from 2001, A Space Odyssey, and the reason I used it was to signify the big move that we are making from monolithic applications to containerized applications, and the way we are doing that is with Docker. So if you don't know, Docker is currently rated as one of the most important tool sets a DevOps engineer should know in 2020. This course is designed to be a one-stop shop for everything you need to know about Docker. We'll start off with a basic rundown of the theory of Docker and containers, and then we're going to hop into the shell, and we're going to go over the practical knowledge that you'll need to know. We'll show you all the commands and the syntax for Docker files, and we'll even get into orchestration. And orchestration is Docker Swarm and Kubernetes, which are also highly sought after skills. As with all my courses, everything you need is in the description below. There's a link to GitHub, which has all the commands I use in my videos, including any included files, Docker files, or configuration files. There is also bookmarks, so you can jump to any section you need, as well as a playlist for all the videos related to Docker. This entire series is no more than a few hours, and it'll give you everything you need to know to be an expert with Docker. So let's get started. Alright, so we're going to start off with a little bit of theory here in regards to Docker and containers. If you want to just jump right into the practical stuff, please go into the bookmarks and then just jump into the lab portion. But if you want to learn a little bit about containers and microservices, please stay with me and we will learn this together. Alright, so in this diagram here, we have two example applications. We have the traditional monolithic application on the left-hand side, and on the right-hand side, we have a more modern microservices-based application. And you can tell just by looking at these diagrams where the benefits sort of lie here. So on this monolithic one, everything is just jammed in together. Everything's in a single process, put on a single server. This can really make developing and maintaining the application a living nightmare for anyone involved. That's why every company is moving towards the architecture on the right-hand side. Where it's Netflix or Uber, I promise you, they're using an architecture more similar to the microservices architecture. No one is developing, I hope, architectures in this old way of just putting everything together. The one on the right, you can scale it so much easier because everything is decoupled. Another huge reason why we split up applications into microservices is because of dependency libraries. If we look at this diagram, we can see the monolithic application is limited to using the same libraries for all of its services, whereas on the right-hand side, different services can use different versions of the same libraries. So currently the best way to host a microservice is with something we call a container. Now a container is a lot different than a virtual machine. Let me pull up another picture here. So I like to use this diagram to illustrate the differences between containers and virtual machines, since people seem to have a really hard time understanding what the difference is. So on the left-hand side, we have the virtual machines, and on right-hand side, we have containers. As you can see, with virtual machines, there's a lot more overhead. With both of them, you have the underlying host operating system, but with the virtual machines, you also require a hypervisor. Your hypervisor is usually your VirtualBox or your ESXi, and then underneath that, you have your actual virtual machines. And those virtual machines require their own guest operating system. So it'll be Linux or it'll be Windows. And then under there, you finally get to your application. So that's a lot of memory and CPU dedicated to this guest OS here. Whereas the containers, they don't require the hypervisor, and they just run on the guest OS itself, as a single process in a different namespace. I know that sounds a little complicated, but hopefully when we hop into the lab, it'll make a lot more sense. But basically, what it comes down to is there's a lot less overhead to run a container than there is with a virtual machine. Alright, so I don't want to bore everyone too much with the theory. I think the best way to learn Docker is to just hop into the terminal, get it installed, and start running some containers. I think seeing it will really just put it all together for everyone. So I'm in a terminal now, and I'm going to pull down a repository I have for this course, and I will do that with the get clone command. And this is the repository that I'll be pulling down. It is in the description below, so please check out the description and clone this directory if you want to follow along. If not, just sit back and enjoy. So it looks like it's cloned. I'm going to hop into that directory that got created, which is docker-vagrant. And let's do an ls. And I can see that there's some labs here. This might not be a full list. This list might be different when you download it, as I might be updating this after I'm done filming this course. But for now, it should look similar to this. And within this directory, you can see there's a folder for each of the labs that we're going to be doing, and there is a Vagrant file. And that Vagrant file is what's going to be building my virtual machine. If you already have a Linux machine, go ahead and use that. But if you want to use my Vagrant file, you just need to run the command vagrant up. And if you're not sure how to use Vagrant, please check out my Vagrant course. I will throw a link in here. So this Vagrant is going to provision, so I'm just going to speed up this video as it's probably going to take up to 5 minutes here. So I'll speed it up and I'll meet you guys on the other side. Alright, so we have both nodes up. And yes, I don't think I mentioned it, but that Vagrant file actually has two virtual machines. And so it made us node 1 and node 2, and that's because later on we are going to be using things like Docker Swarm and Kubernetes, and these are orchestrators, and basically it makes it so you can have multiple nodes, and they're going to orchestrate bringing up containers and maintaining containers. So may as well get both nodes created right now. So since they're created, let's hop into the first one, and I'll do a vagrant ssh node 1. And if you want to follow along with your own machine, that's fine. So I'm using Ubuntu 18.04, so if you're following along, you may want to have the same version just so everything's consistent. So I've cleared the screen here, just so you can see what I'm doing. And I'm going to pull up GitHub, because you may want to use this while you're following along, just so you have all the commands. But if you go in there, and we're on lab number 1, getting started, all the commands are in here. So we've done vagrant up, and we've gone into our node 1. The next thing we're going to do is we're going to update Docker. Sorry, we're going to update our apt repository, then we're going to install Docker. So let's do that. So we'll update our apt repository with a sudo apt update. And then we're going to do ampersand because we want to chain this command, and we're going to do a sudo apt get install docker.io. So make sure to do docker.io and not just docker. And then I'm actually going to add some additional syntax here, which is the -y flag. And I'm going to add this to both of my commands here. So sudo apt update -y, and then sudo apt install docker.io -y. And the reason I did that is because I want to go grab a beer while this runs, and the -y will accept any of the prompts. But if you want to get prompted, just put it in the way I have on GitHub. Anyways, I will speed up the video so you don't have to watch this install. It will take up to 5 to 10 minutes, so I'll be back in a minute here. Alright, so it looks like Docker has installed. So I'll clear my screen here, and I will start off with the sudo docker version. And you can see that there's two components that came back with this command. Excuse me. There's the client as well as the server. So the client and the server are actually decoupled. You could use the local client on this server to talk to another server located on a different server, and you can talk to it using the client CLI, or you could use the API. So we're just going to be using the local client to talk to the local server, and you can see we're using version 19.03.6 for both the server as well as the client. But feel free to use any version of Docker, but preferably a version that is greater than 19.0.3. So that's the first command. The next thing we want to do is a sudo docker info. And I'll scroll up here. We can see that it just gives basic information in regards to the Docker server. It shows the amount of containers that are running, pause, and stop. It shows the amount of images, but we don't have any images or containers running yet. So let's move on and get those going. So I'll clear the screen once again. And before I get a container running, I'm going to put together some aliases that I like to use. So right now, if you do like a docker ps, you get permission errors because I'm not root. But if I did sudo docker ps, you can see that it returns some information. So instead of typing sudo docker every time, I'm going to create an alias here just called docker. I'm going to go equals sudo docker. Now when I run docker and any command, it returns it. So I don't need to do the sudo anymore. Another thing that I like doing is instead of typing out docker, I rather just type d. So if I go alias d equals sudo docker, then I can do the same thing. Like I can do a d ps, and that's the same as doing docker ps. And like if I do d images ls, I can see the images. So those are two aliases I always set up. Another one that I like doing, I will copy and paste them in, is the stop dockers or the stop docs alias, and you can see that it does the sudo docker stop command. This stops a container, and for the input it's taking in the docker ps command. So it's basically listing all the containers and sending that as input to the docker stop command. So I like using this so I can stop all the containers at once. And I also use this one called remove docs, and this will remove all the Docker containers. So I like using that in the lab environment since we're bringing up a lot of Docker containers, we're doing testing. It's just a lot more efficient to do stop docs and rm docs. So those are the aliases. The next thing we want to do is let's look at the images. So if I do a docker images ls, I can see there's no images right now. So let's go ahead and pull an image. So let's do a docker pull, and the image we're going to pull is called Ubuntu because we want to pull an Ubuntu image. And we want to specify the version. So we're just going to do a colon and then 14.04. So on the left hand side is the repository, and on the right hand side is the version. So we're pulling from the Ubuntu repository, and we want to use the 14.04 tag. So we're doing that. You could also do something like, if you wanted to do version 18, you could put 18.04, or if you wanted the latest version, commonly used tag is latest. But I want to use 14.04 because I've tested the labs using that version. So I'm doing this, and this is pulling from Docker Hub. Now, Docker Hub is a website that you can search for images. You can do it through the command line as well, but it's easier just to come to Docker Hub. And if you search for an image, you can see I searched for Ubuntu here, and you can go in here, and basically it has all the images related to Ubuntu. If you wanted something else like CentOS, you could search for that, and they have an official repository. So any major Linux software will have a repository, so you can find it on Docker Hub. And we're using this one. These are the various tags you can use. As I mentioned, I'm using 14.04, but you could do any of these other versions, or you can do something like latest, and you can see there's other ones like trusty and rolling. But we'll use this one, and we can see that the image has downloaded. So now if we do a docker images, we can see that we're getting some output here. So we have the Ubuntu repository, we have this image tag, and it's got an image ID, and you can see that it's 200 megabytes, and it was last changed or created 3 months ago. So it gives us information. So that's the image, but right now if we do a docker ps, we can see that there's no containers running. So we have our image created but no containers. I'm going to go ahead and run a container here. So to do that, we just type docker run, and I'm going to use -it as a parameter, and this is commonly used if you want to interact with the container. And I'm going to put the image name, which is Ubuntu 14.04. So we can see that we got a change here, right? So we're actually sitting in the container right now. And just to prove it, if you do a host name, right, we got a strange name. It's not the node 1 that we're in before. And if we do uname, we can see Linux version. I was expecting something else there. I think I wanted the LSB release, actually. So if I do that, no, that's not what I wanted either. Okay, the command I was looking for was lsb_release-a, and I can see that the release version is 14.04, which is the container that, or sorry, which is the image that we downloaded. And if I type exit here, we can see that we're back in node 1, and if I do the LSB release, we can see that this one's 18.04. So you can see that the container was running a different version of the operating system. So its environment is completely different than the host operating system it was running on. Now let's do a docker ps. And as you can see, there's no containers there. So let's add the flag -a, which means all. And we can see that there's a single container. It was created 2 minutes ago, but the status is it exited. And that's because we exited from the bash shell, and the container will only run for as long as the entry point process runs for. So since we exited the bash shell, that process died and the container stopped. So what we could do is we could run that same command to start the container again, but this time let's do -d, and this will run in detached mode. And as you can see, we didn't remote into the container right away. And if we do sudo docker ps, we can see that there's another container, and this one was just created 15 seconds ago, and it's up and running. And if we wanted to interact with that container, we could do sudo exec, and we could do sudo exec, and then we want the container ID or the container name, which is over here. You can't see on my video screen, but it's a little further over here. So we could use this or the container ID. Let's stick with the container ID. So we'll put this here, and we want to run a command, so I'll just say hostname. And we want to run docker in front of the exec, and we don't need sudo. So just docker exec, the container name, hostname. Hit enter, and you can see it returned the hostname. And we could do more. We could do lsb release. And you can see that it's returning that version number of 14.04. So we're interacting with the container from our host operating system. And if we actually wanted to hop into that container, even though we started in detached mode, we just do a docker attach, and then we put the container ID. And we should be in there. Yes, we're in the container. And I'll just exit out. And if I do docker ps, I can see there's nothing there. And if I do -a, I have the two containers that I created, and they both exited. So that's exactly what we're expecting, and that's sort of just how to easily create containers and interact with them. So I hope that made some sense there. That's the basics to getting started with Docker. So in my next video, I'll get a lot more in depth on what an image is and what a container is and how they interact with each other. So I hope this video was helpful. If you found it helpful, please like the video. If you would like to see more content from me, please subscribe. And I hope to see everyone in the next video.